Hello and welcome to Instant Insights. I'm Jordan Strzelecki, an analyst in Global Data's Strategic Intelligence team. At Global Data Strategic Intelligence, we track over 100 tech, industry, ESG, and macro themes impacting all major sectors. In today's episode, we're going to be looking at agentic AI, including what exactly agentic AI is, the major players developing it, the real-world applications we're seeing in the field, and much more. Today, I'm joined by William Rojas and Isabel Al-Dhahir. Bill and then Isabel, could you please introduce yourselves to our listeners?
Sure. I'm Bill Rojas. I'm the Director of Research in Strategic Intelligence. I'm based in Hong Kong. My career has been in both engineering, electronics, and analyst work and consulting the last 25, 30 years.
Hi, everyone. I'm Isabel. I'm a principal analyst. I work with Bill in the strategic intelligence team at Global Data, and I manage many of our projects on AI and emerging technologies.
Brilliant. Thank you both. So to kind of kick off our discussion, I think it's useful for us to kind of begin with some of the broader context surrounding agentic AI. So Gen AI, of course, burst into the public eye when OpenAI launched ChatGPT in November 2022. ChatGPT quickly went viral, going from 0 to 1 million users in less than a week. And its release was really a watershed moment because even tech experts were surprised with just how good it was. We've since seen an AI arms race unfold, with tech giants developing their own Gen AI chatbots and businesses rushing to implement AI into various aspects of their operations. We're also now hearing more and more about agentic AI in recent months. But of course, AI's roots go much deeper than these relatively recent developments. So, Bill, could you provide our listeners with a high-level overview of AI's history from its inception through to ChatGPT's release in late 2022 and to where we're at today in 2025?
Sure. So the AI research actually began in the early 1950s when Marvin Minsky, professor at MIT, who later founded the MIT AI lab, built a neural network simulator. It was actually in 1951. The idea was to actually try to mimic what was understood about neural networks, biological neural networks at the time. And that was the reason that Marvin Minsky did the neural network simulator. In the ensuing 20 years, the AI research, besides looking at biological neurons to understand how they work, started to also look at rule-based systems, rule-based AI systems. And in the early 2000s, this is when machine learning started to take off and adaptive agents and AI agents started to appear. And between the early 2000s and 2020, 2015, a lot of research and development took place on machine learning. Much of this was using statistical techniques, things like Monte Carlo, also things like reinforcement learning. Many different types of algorithms were developed for different types of machine learning, for example, pattern recognition, or looking at a large database of unstructured data to look for patterns. And that was through, let's say, 2010, 2015. Now, at the same time that was all taking place, researchers at places like Google were developing what later became the transformer, and that is the foundation of the generative AI models. And the seminal paper that was published by Google occurred in 2017. And that would be pretty much how, the beginning of Gen AI. The public didn't really know about this research very much until ChatGPT and OpenAI made their announcement in November 2022. But the technology that ChatGPT deployed actually came from Google's publication in 2017. AI agents throughout the last 20, 30 years actually have been developed over time. What is significantly different, and the reason that AI agents now are kind of rebounding, is that having the ability to connect to the large language models gives the agents a lot of flexibility, and they can start to apply reasoning and other capabilities.
Brilliant. Thanks, Bill. As we've alluded to just there, AI has developed rapidly over the past few years, and this growth is only set to accelerate. So we see hyperscale data centers dedicated to AI springing up all over the world. Bill, can you just give us some top-line figures on just how big the global AI market is expected to become in the coming years?
Right. So this is a little bit like Carl Sagan, for those that are familiar. He used to talk about billions and billions of stars in the galaxies in the universe. Well, the AI market is definitely going to be trillions of dollars. Global Data's current forecast is roughly $1 trillion by 2030. And the AI market is kind of split between two types of technology. One is what we'll call predictive AI. That's the machine learning algorithms. That's going to still be through 2030, probably 85 to 90% of the market. And the remaining 10 to 15% is going to be Gen AI based applications. An example would be conversational platforms, chatbots, intelligent chatbots. These will grow, and this would be classified as predominantly a Gen AI application. In terms of companies and revenue, there's not a lot being reported by the listed companies, but OpenAI, for example, is expected to have revenues this year on the order of around $12 billion. But we should point out that the business model is such that they don't own the infrastructure. They're leasing it from Microsoft Azure, and Azure is being paid for the hosting of the servers.
So over the past 6 months or so, you, our listeners, have probably seen the terms agentic AI and AI agents cropping up more and more in the news and perhaps in your internal boardroom discussions. I know, Bill, you mentioned AI agents in your kind of timeline going back several years. But Isabel, can you just be a bit more specific? How would you define agentic AI, and how do AI agents differ from the AI assistants or chatbots we're already familiar with?
Sure. So agentic AI refers to AI systems that can reason, act, and learn with far greater autonomy than today's AI assistants. So, for example, if we think about Apple's Siri or Amazon's Alexa, these are AI assistants, and people who may have used them, particularly the early versions, will know that their functionality is quite limited. They don't hold much memory, so they don't have prior context of your conversations with them. And they fall under the reactive AI category, meaning that they hear a certain word and they give a certain response, but nowhere near the level of sophistication that agentic AI has, which is able to hold memory and also perform complex reasoning. And this far greater autonomy means that agentic AI or AI agents, they're capable of performing tasks from start to finish with minimal intervention. And the analysts here at Global Data, we think that agentic AI is going to be very impactful, particularly for enterprise use. As Bill expanded on, there's a whole timeline leading up to this moment, and particularly for enterprise use, agentic AI should be a lot more attractive to integrate into various use cases compared to pre-agentic forms, where you still needed to have a lot of human supervision. I mean, for example, if an AI tool is correct only 80% of the time, it can be argued, what's the use of it? You'd still need your traditional human workforce to constantly check it and come to the rescue. And in many respects, that negates the productivity savings. But agentic AI or AI agents, they're being built with superior reasoning, and they're intended to operate more independently and autonomously. And so that's the next phase that has now been unlocked for businesses.
I know at Global Data, we've identified several classifications of AI agents. Bill, can you just spell these out, please?
Sure. Currently, there are about 6 or 7, so half a dozen classes of AI agents, and it's basically based on whether or not it has a memory, what the AI agent's ability is to interact with the external environment, to get access and information, search information outside of its own environment, and the ability to learn and to critique itself and to improve itself. So I'll give you some examples. Oftentimes you might, when you walk into an office lobby, you may see a cleaning robot. And it turns out that that's actually an AI agent, because if you kind of watch the cleaning robot, it doesn't get into a repetitive cycle. If the robot didn't have some intelligence, what would happen is it would get to a corner and it would just go spin around and get stuck in the corner and never move. And so what is actually happening is the agent that's driving the robot is creating a map of the environment that it's serving, and it's making sure that it's not repeating over and over, so that it spreads across the whole space that it needs to cover. That's called a simple reflex agent. Take another kind of agent. Let's say that you were to develop a home security system, and of course, in the home security system, there are situations that are not necessarily predictable and maybe had not been designed into the software. So for example, would be, let's say a bird crashes into the window, right, and sets off the alarm. The AI agent would have to learn about this, and it would have to go to the cloud and update the cloud so that other agents would also be able to deal with these different situations. And that's called a model-based reflex agent. Another example would be learning agents. These are agents that their primary job is to actually learn everything they can from the environment and what's happening, and to have a way to critique its performance and to improve its performance. So it becomes essentially what we would call reinforcement learning. One of the most famous AI agents that was developed was actually done by Google. It was called AlphaGo. And it was a program that had been developed to play the game of Go, which is an East Asian chess game that you'll see in Korea and Japan and in China, quite popular. But it's a very difficult game and it requires a lot of strategy. So Google, what they did is they fed past matches into the AI agent. And at some point, it kind of got to a plateau and it couldn't really improve itself. Didn't know what to do. So Google had an idea. Why don't we teach the agent to just create its own games? Right? Kind of like an intelligent solitaire card game, if you're familiar with solitaire. And what happened was it started to create games, and it started to learn from its games and started to beat its games. And eventually, after a few months, it was so sophisticated that it was able to take on masters, and it was actually a champion and beat world masters. So that is an excellent example of an AI program that had been basically changed midway to make it smarter. And the last thing I want to mention is what are called multi-agent systems. These are particularly important for industrial applications, and where the problem that you're trying to manage, or operational problem that you're trying to manage, is too complex for a single agent to do it. So you break it into different tasks, and each of those agents then has to communicate with the rest of the agents. They may have a common memory, common protocols, common methods of evaluating performance. And that's a multi-agent system. So it's pretty complex, a lot of interesting things going on, plenty of opportunity for software programmers to innovate.
Great. Obviously, as you said, we've kind of got half a dozen categories for classifications of AI agents. Isabel, who are actually the major players developing agentic AI, and which startups should our listeners be keeping an eye on?
Sure. So in terms of companies developing agentic AI, there are all the expected household names. You've got Microsoft, Google, Amazon, OpenAI. Google actually says its Gemini 2.0 model is expressly designed for the agentic AI era. However, we're also seeing several agentic AI startups emerging, and some of these are set up by former employees from those major players. So for example, some of the listeners here will be familiar with the name Mira Murati. She was the former CTO of OpenAI. And she left, if I recall, in September 2024. And earlier this year, she launched Thinking Machines Lab. And it's very early days, so I can't speak of what its products will be, but it seems to be pursuing multimodal agentic AI. And there are reports that the startup Thinking Machines Lab is trying to score about 1 or 2 billion in funding with a valuation of about $10 billion. And that's, like I say, without any products to even vaunt. Another startup is the French company, which goes by a single letter, H. It was founded by former Google DeepMind employees, and its niche is agentic AI coupled with vision language models, meaning that the AI can interpret and interact with graphs and diagrams and other kinds of video image data. And it was founded in 2023, and within just a year, it raised $220 million, so quite a strong start. However, something I want to add to this is that when talking about startups to watch, it's important not to just focus on the clear success stories, if indeed any do exist. A lot of startups, particularly AI ones, are created by visionary thinkers who want to do something new and exciting. However, because building large language models is so resource intensive and expensive, these startups end up relying on big tech money and very large investments. And gradually they end up losing at least a little bit of control over their initial direction. We saw this play out in public with OpenAI. DeepMind and its acquisition by Google was not without its own share of internal strife. H, the French startup I just mentioned, it was founded in 2023. By mid-2024, it had lost 3 of its 5 co-founders, and it's rumored that this is because of too much investor-side control. So for any of our listeners who are interested in AI startups, it's useful to also study the the more tumultuous elements as well, and how direction can easily change due to the operational demands of AI.
So, Bill, obviously, I know you touched on AlphaGo and kind of self-cleaning robots. Can you just share a few examples from industry where agentic AI is already being deployed to great effect?
Yes. The example I'd like to use today is a system that was developed by Toyota in Japan. It's called the Obeya system. And the purpose of the system is to manage and improve and enhance the engineering and development of the powertrain system in Toyota automobiles. So what is the powertrain? That's the system that delivers the power to the wheels so that the car can move forward. It includes the engine, the transmission, the drive shaft, axles, differential. If you're talking about electric vehicles, it also includes the battery, the inverter, and the electric motor. So it's a really complex system. And what Toyota discovered was that even though they have 800 engineers working on powertrain, what happens is every year a handful of senior engineers will retire. And with them goes all the incredible knowledge of 20, 30, years in the career. And so what they wanted to do was to have a system that could capture the intelligence and the wisdom and the know-how of the senior engineers, and at the same time act as a way to facilitate the development. So what they did is they developed 9 different agents. So they have an agent for battery development, one for fuel efficiency, one for knowledge sharing, that's to get the information from the senior engineers, motors, regulation, system control, vibration, and fuel consumption. And what's interesting is the whole thing was done on Azure OpenAI large language model architecture. And essentially, every time an engineer, let's say, had a new idea and he wanted to test the idea out, he would have to have the fuel efficiency agent or the regulation agent or the system control agent take a look at what he had designed. So this is a very sophisticated system, and we could classify this essentially as a development system. But it's an excellent example of how you can have multiple agents working together 24/7 to solve specific problems.
And of course, no technology matures without friction. Isabel, can you just touch on what are the biggest operational challenges industrial and operational technology companies face when trying to implement AI agents? Just like the ones obviously Bill's just touched on with Toyota, for example.
Yes, so specifically industrial type companies, well, they need really good data security and also low latency, which means very fast data transmission speeds from one location to another. And these 2 factors are more to do with the supporting infrastructure for AI, such as the cloud or edge, where the data is stored and handled. And there are massive investments across the world in creating data center hubs exactly for this reason. A lot of investment in local data centers throughout the world, not just in the US and China. And this is particularly relevant for these kinds of multinational companies or industrials companies with very stringent real-time data transmission requirements. For example, if you're operating in Australia, you don't want to be relying on a data center in Northern Europe. You want access to geographically more local infrastructure. The other point to consider is training data quality. So there are already concerns about a shortage of data as a whole, but even more so is that true for maybe niche use cases and applications. The quality of the AI output is very much contingent on the quality of the data that it's trained on. And actually, a lot of conferences that I've been to, this is a topic of much discussion, and some do see training data or the lack of as a limiting factor.
And I guess we kind of tag on to that. I guess we've kind of seen a transition to smaller language models to try and get better outputs based on the training data inputs, right?
Yes, I mean more constrained training data sets, yes.
Okay, thanks. And for our final question, I just want to touch on the important issue of AI ethics. So as we hand over more decision making to machines, ethical questions obviously only multiply. So Isabel, how do you see the emergence of agentic AI reshaping debates around AI safety, responsibility, and governance?
Yeah, so the objective for companies employing AI agents is precisely that they operate with minimal human supervision. And that requires high levels of trust in the quality of each step of the AI's reasoning. So there need to be strong guardrails to ensure that the AI agent conforms to the values and principles of the organization, and also to the relevant regional laws regarding areas like data privacy and anti-discrimination. And the AI would need to take those guardrails into account every time it's prompted to do something. It would be a huge reputational risk for a company to employ an illogical or discriminatory AI. And actually, I'll go a bit further. It's not just reputation at stake, but poor reasoning skills lead to poor decisions and ultimately will certainly affect the company's financial performance. So ethics and regulation are often seen as red tape burdens, but ignoring it could lead to self-inflicted wounds. I also want to talk about the adjacent area of the impact of agentic AI on the workforce. So far, a generative AI has not impacted the workforce significantly, despite many concerns voiced back in November 2022 when ChatGPT was released. And this is because thus far, generative AI has not demonstrated sufficient independence or accuracy. However, with the advent of agentic AI and reasoning models, the impact on the workforce will be felt much more so. Because to put it simply, that is the objective. You'll see several agentic AI startups aimed at workplace efficiency, listing reducing headcount growth as one of their key benefits. And translating that from like PR speak, that means a smaller or more limited human workforce. Now, I'm not saying that this is inherently unethical, but leaving it unmitigated could be. And there's now an onus on education systems to prepare younger generations for a future where they can be productive and find employment alongside AI. And there's actually an interesting study that Anthropic published earlier this year looking at millions of conversations that took place with the AI model Claude and analyzing the kinds of skills that were required of the AI model and also the jobs that were predominantly using it. And they found that software engineers and software developers, they were the highest users as a percentage of the total. And so while AI is clearly proving useful to these roles, the increased dependency makes these roles particularly vulnerable as AI becomes capable of doing more and more of their job for them. And of course, also many other jobs will also become increasingly vulnerable where AI can supplement more and more of the work. So the topic of AI, it covers multiple bases. It's not just a question of the AI in isolation, but also the consequent impact on society and how we can prepare for it.
Brilliant. Thank you. And unfortunately, that's all we have time for. Thank you, Bill and Isabel, for joining on today's podcast on agentic AI, as well as our listeners for tuning in. So if you have any questions or want to get in touch with our team at Global Data Strategic Intelligence, you can reach out at customersuccess.strategic@globaldata.com. Thank you once again for listening, and to Bill and Isabel for joining, and see you next time.